This power supply converts 115 volts, 400 hertz, to 13.8 volt DC. See that we're driving a light bulb here. I'll show you some of the waveforms at various points in the circuit. The first point is at the secondary here. The 115 volts is stepped down to 13 volts, 400 hertz. See on the scope a nice clean sine wave. It's 400 hertz. The RMS value is 12.7. The peak-to-peak value is fluctuating between 36.4 and 36.6. We'll say it's 36.4. An important point that I'd like you to remember is that the peak-to-peak value is 36.4. The peak value, or the point from the zero line here to the top of one of these sine waves, is about 18.2. The value from the 0 point to the negative point is negative 18.2 roughly. The output from this secondary of this transformer is connected to the bridge rectifier here and here. The output from the bridge rectifier is between here and here. I'll show you what that looks like on the scope. It's going to be a pulsating DC signal. You can see a really nice, clean, pulsating DC. One thing that you'll want to notice is that the frequency has increased from 400 hertz to 800 hertz. Later on, I'll show you a diagram. I'll explain why that happened. Another important thing to note is that the peak value, now there is no peak to peak here. Here's 0, here's the peak. The peak value has decreased. You remember when it was coming out of the secondary, I told you that the peak value was roughly 18.2. Now you see the peak value is about 17 volts. So we've lost 1.2 volts somewhere. I'll explain that again on the diagram when I bring it out in a couple minutes. But if you recall from theory, you're going to lose between 0.5 and 0.7 volts across the diode. This voltage that you're seeing has gone across two diodes to make the peak. So 2 times 0.5 would be 1 volt, and if it was a 0.6 drop, it would be 1.2 volts. So the 1.2 volts that we lost is due to the fact that the voltage drop across each one of these diodes decreases the final output. I'm going to put the capacitor, this filter capacitor, across in parallel to the output of this bridge rectifier, and also it's going to be in parallel to the load. And you're going to see two things happen. This light bulb is going to increase in intensity or get brighter, and this pulsating DC signal is going to become a straight line. So watch the light bulb and see that got brighter, and over here you can see that we have a fairly steady state DC signal. Pull it out again, put it back in, light bulb got brighter, pulsating DC became a steady state DC. Now you can see that the mean voltage or the average voltage is 13.8, and the process of smoothing out that ripple or that positive DC pulsating signal, it became 13.8 steady.